Good afternoon, everybody. Thanks for joining me. I'm going to go on record and say that I get the opportunity to speak to a lot of large rooms, but sometimes people forget to fill them with people. So thanks for joining me on your lunch hour today. So today's topic, I want to talk about digital twins. Digital twins are not a new concept. They've been around for years. But frequently, historically, what we've seen is that they've been hand-rolled solutions by large organizations with many, many lines of source code to them. Nowadays, what we're seeing is there are digital twin platforms coming online, solutions that make the usage of digital twins much more accessible to smaller organizations. What we're going to look at here today is to take a look at the digital twin itself, understand what are the security implications of that, and how does this play into and become an attack vector into our actual physical systems. There we go. Okay, so for an agenda today, we're going to start off with what is a digital twin. We'll just go over what are digital twins, what do they do for us, and exactly what's their purpose. Then we're going to go into some of the threats associated with the twin. What are the attack vectors associated with them, and how can they be exploited by a hacker? Then finally, in our third part, we'll just sort of go into what are the things that we can do to that digital twin to ensure its hardness and verify that we know that we have a secure solution and does not compromise potentially our physical systems. So to start off with, what is a digital twin? And I'm going to caveat this right now. This is arguably one of the most overused terms, besides Internet of Things, of course. But digital twins mean a lot of different things to a lot of different people. But ultimately, what we're talking about with regards to these concepts are going to apply kind of to every different level of those implementations. So people are implementing digital twins in different ways, and ultimately these concepts, I think, apply across the board. So what is a digital twin? According to General Electric, a digital twin is a dynamic digital representation of an industrial asset that enables companies to better understand and predict the performance of their machines and find new revenue streams and change the way their business operates. In other words, it's a simulator. We want to simulate something in a digital environment. This allows us to optimize things. This allows us to create better designs. And it allows us to simulate these things in non-physical environments. Industrial control systems, as we know, are capital-intensive endeavors. And by being able to have a digital twin to build these systems, simulate these systems, and the like, what we can do is we can verify these things before going to the physical systems, make sure we don't break anything, and make sure we don't hurt anybody. So how are digital twins used? First off, in the design phase. Digital twins, I used to be a CAD draftsman back in the old days, so I think of digital twins as an evolution of CAD. Basically, we started off in the old days with two-dimensional CAD drawings, where we were drawing digital drawings of blueprints. Then we went to three-dimensional objects and 3D modeling, and we were able to model the physical properties of things. And digital twin seems like the next evolution of that, where you're now taking it into a fourth dimension. You can put these three-dimensional objects together into systems, and you can run them over a period of time and understand how the behavior of this system works. So design is very important with regards to the digital twin aspect, and I think that's where a lot of the starting point is for a lot of companies with regards to twin implementation. Second is operations. Once you bring a big system up, you continually have to operate that system, and ultimately we can map the design aspects of the system directly into operations and ultimately start collecting data off of that system. We now live in the age of big data, machine learning, artificial intelligence algorithms, and as such, this data can continue to make the digital twin evolve and ultimately optimize the performance of the physical system itself. So as we collect information off the physical system, the twin continues to evolve, and then we can push updates out to the physical system as we gain trust in those updates. Next, service and management, or service and maintenance. Industrial control systems, building information systems, all of these things have components in them that are designed to last a long time, and they have maintenance to them. Light bulbs need to be replaced. Motors need to be oiled. Air filters need to be replaced. So ultimately, by having this digital twin, we can track all of the components within this complex system, and we can manage those throughout the actual operation lifespan of the system. And then finally, safety. We've heard the word safety a lot today, in particular that security roughly equates to safety within the industrial control environment. We need to know that that system is operating consistently, and we need to know that our controlled explosion is going to maintain control, and also a robot's not going to come off and smack somebody in the head, and digital twins can be used successfully to simulate these environments and understand them before we go to physical. So, what is a digital twin to a hacker? Well, ultimately, we're trying to make the twin as perfect of a replica as possible of the physical system. Our goal with that is to get the best results with regards to our simulation and our usage of it. So ultimately, in the hacker's hands, if they have control or access to that digital twin, they more or less have a model of your system. They can look at that digital twin, they understand how your system is laid out, and they can use that to understand everything about it. And one of the defining mantras of the security industry is that anything that you can do with a tool, a hacker can do also. We frequently forget that. We frequently say, okay, that's just not a use case that I can possibly see anybody ever doing to my system. If you can say that to yourself, more than likely somebody's going to try it. So ultimately, we need to remember that any technology that comes out, while it can be used for good, it can equally be used for bad. So with that, let's get into some of the threats. So as I mentioned, in the hands of a hacker, this more or less lays out your system design to the hacker. So disassembly of that code, and I literally had somebody one time say to me, we don't hand out our source code. We literally compile it into a binary, so what's somebody going to do with that? Well, I can tell you right now, a hacker is going to do a lot. There are very sophisticated tools out, and me as a hacker, what I'm going to do is go in, scrape your binary image, run it through a tool that disassembles it, and it will literally bring it back into a source code flow type format. So if you don't know of any such tools like this, IDA Pro is a very common one that's used by hackers. And if you go and look at actually the functionality of it, it will literally disassemble this for you. By doing that, the hacker now has a blueprint of your system. The hacker goes through your system, identifies where your vulnerabilities are, and then uses that to make an attack plan on your physical system. So ultimately, again, the better the representation the digital twin is, the more of a threat it potentially is to your physical system, because you are potentially providing the hacker with more information. Now, the hacker has a plan to attack your physical system. And so what does he do? He uses the digital twin to exercise it. He first of all uses the twin, tries to exercise his penetration plan through that, and once inside, let's say he hits a barrier, what does he do? He reboots it, starts over. So this allows the hacker to iterate over and over again with regards to the attack plan. This is not too dissimilar from the design process that you were using the hacker or the twin for initially. So ultimately, the ability to have this digital twin and iterate over repeatedly allows the hacker to refine that plan down to a perfect attack plan. Similarly, if he goes to a physical system and he starts actually hitting firewalls and the like, there's going to be a bunch of alarms going off, and there's going to be IT guys going, hey, there's something going on over here. So if the hacker gets past point A within your system, IT detects it, they may shut down that point, that now puts the hacker back to square one. With the digital twin, he doesn't have that problem. He can repeat again, over again, until he refines that plan. Backend system attacks. As we all know, physical systems nowadays have lots of back-end systems that are supporting them. There's databases, there's data stores, there's machine learning algorithms and things that are occurring up in the cloud. Those physical systems call via APIs into those systems, and frequently if you're going to build a digital twin, you may not necessarily replicate those back-end systems. Those are big, expensive systems, and so what you're going to do is you're going to have the twin just call into those back-end systems, maybe create a test account or something like that within it for it to function, and ultimately that'll basically allow the twin to function. As a hacker, I may be using your twin as an entry point into those back-end systems specifically. This could be customer data back there. Ultimately, it's going to be valuable proprietary data that's yours. But once I scrape that binary image, I go through there and figure out where the back-end system calls are. These are usually in the form of APIs and the like. And then on top of it, there are going to be frequently some sort of credential for you to get access to that API, either username and password, possibly a PKI certificate or something of the like. Well, in order for the twin to call that, it's got to be embedded in there. And me, as the hacker, by reverse engineering it, I now have access to it. So ultimately, we can look at the twin, and this is, I frequently talk in specifically IoT environments, and this is one way in particular to look at the IoT space. By spreading a bunch of devices throughout the world, you're now creating all these entry points into your back-end systems. And this is a very similar application here. IP protection. Let's assume that the hacker is not a malicious hacker necessarily, but your competitor. And ultimately, again, we're saying the best digital twin that we can make is one that most accurately represents our physical system. In order to do that, we have to start implementing our intellectual property into that twin also. So ultimately, you're exposing your trade secrets if somebody gets access to that twin in the future. So how do we protect them? First of all, design security in. One of the big things that you have to remember is when you're designing a digital twin, you have a physical system that you're creating an analog of. And you need to treat that digital twin as its own entity with regards to its protection. In particular, there's going to be a lot of assumptions that are made within the design of the twin about your physical system. And your physical system may have hardware support systems within. Industrial control systems, consumer electronics devices, all of them nowadays are coming with what's called secure micro or a hardware root of trust within it. It has a secure hardware operating environment, which is very secure in practice. But if you now take that over into, let's say, a PC platform, you don't have access to that hardware. So what you're going to do, let's say that there's a cryptographic operation occurring on that physical system. I take some sort of cryptographic software library and drop that into my twin. That is now vulnerable. I have keys in there, I'm doing cryptographic operations, and if I put this on a debugger as a hacker, I'm literally going to see directly into these cryptographic operations that are occurring. So ultimately, we need to think of the twin as a separate entity from the physical system in order to protect it, because PC platforms are not secure. There are hardware security modules within them, but frequently you don't have access to them. Software protection. Software protection comes into play when the scenario that I just described to you is we are now doing secure operations within a software environment. If I can put a debugger on there and I can observe these things occurring in real time, we ultimately have no security around them. Software security allows us to build boxes around certain areas of code, in particular cryptographic operations, API system calls, and the like, such that we can essentially make that code unreadable to a potential hacker, make it difficult to impossible for him to disassemble it. And this creates additional security around the twin itself. And then finally, copy protection. Obviously, the easiest way to prevent a hacker from using your twin is to prevent its distribution. This obviously has to be coupled with access policies within your facility. But by starting off with, we know that all software is copyable. If we can bind that software to a piece of hardware, and you can do this with a PC, bind that software to a particular machine such that if you're going to steal this twin, you physically have to take the machine, at which point you can create facilities, policies around the handling of your twin to make sure that it does not leave your facility. But ultimately, a piece of software on a computer is easily copyable and can either be done by an insider attack, potentially, somebody within your own organization, or through poor IT policies where they can potentially come in through your back door and get to your twin from that perspective. So ultimately, binding that twin to a piece of hardware is important. And there's good copy protection and bad copy protection. I always use the analogy of Office 97. Does anybody remember Microsoft Office 97 and it had that 16-digit code that you had with it? Well, you can copy the 16-digit code and share it with your friend as easy as you can copy the CD. So ultimately, that type of copy protection is useless, as Microsoft has figured out. But ultimately, we can tie it to the machine through some sort of physical hardware binding such that that software is not easily copyable. And with that, I'd like to open it up for some questions. Crickets?
Hi there.
Hi.
I used to be a programmer for a company called CAE Link, and they were doing dynamic simulation where you write a program and then you connect it to a DCS system for training operators and that sort of stuff. This is back in 1994. Hasn't this digital twin thing been going on for a long, long time?
Yeah, I think the digital twin has been going on for a long, long time. Like I said in the beginning, I think that early that these implementations were very much proprietary. So you had in-house written solutions, and you had to have an army of software engineers to build it. The big thing is why it's of interest now, I think, is there are solutions, canned solutions coming out that make it much more approachable to smaller organizations. And I think that's where we're starting to see twins popping up more and more with regards to their usage. And I think that's why it's really gaining relevance now.
Hi. One of the things you talked about a lot is when digital twins are used for design, and you're designing a new plane, new model, new factory, whatever. But once you build this digital twin and you have an existing facility, which you have to update on a regular basis because you're changing the facility, how do you protect it in that security? Because you have to feed in new data all the time to the digital twin to keep it up to date.
You're absolutely right. And that comes down to good IT policies with regards to protecting that data feed. Ultimately, I'm concerned with protecting the twin itself. And there are lots of IT mechanisms that are going to feed into this. And to do that, you would need some sort of dedicated VPN type connection coming from the actual physical system to protect the data getting to the twin itself. And ultimately, again, we need to ensure, again, the software can't be copied and that physical system is some sort of secured environment within the facility itself. Okay. Thanks, everybody. We're here all week on the show floor, and our team from Irdeto here is with us today. So stop by and see us when you can. Thanks, everybody.